Hi, this is Project Crosstalk, enabling smart search for SDGs by SAFE LLC as part of the G4ALL 2022 challenge sponsored by TigerGraph. Information regarding SDGs is usually in the form of PDF reports, which are often broad in and across reports, disparate and difficult to act upon. This solution addresses this information gap within and across these reports and implements text mining, NLP, and graph database technology to take the broad, disparate, sometimes overwhelming and unactionable information and make it organized, targeted, usable, and actionable. This demo with more detailed instructions in the GitHub repository will cover pre-processing scripts, graph schema design, and graph query development using R, Python, and TigerGraph. First, employing PDF scraping and text mining. An R script was written to take an individual PDF report, extract the text, and output a CSV of a data frame containing the information in that report. Using NLP technologies and a variety of R NLP packages, a corpus of the text and a term document matrix is developed. Sentiment analysis is performed. And extraction of some desired features is also performed. Here, extraction of some SDG related content in a document is performed, as well as continent. Here, countries as well. Some data visualizations of the features that were extracted. And at the end, an output of that information as well as CSV files. This is done per document, and eventually the results are comprised across all documents in a data store. Some examples of what this NLP can cover, for in this case, document 3, the primary SDG discussed in this document was energy. Here shows a distribution of the sentiment across this particular document, where trust and anticipation were the highest. Again, this is document 3. Document 7, the primary SDG covered in this document was poverty, where the sentiment analysis results differ quite a bit, including fear and sadness more so than the previous one. So this is some of the work that was done as part of this solution on the extraction of content and information from PDF documents. Those are combined and leads to our schema design, where in this case nodes are the organization, the report content, the page number of the report, the SDG content, the sentiment content, as well as the content, and edges representing the relationship between reports and those nodes, and some interrelationships between the, in some cases where more than one SDG is covered and or more than one sentiment is covered within the document. A functional demonstration of this type of approach, I'll pull it up here and demonstrate, where the docs is the main node, SDGs, sentiment, and continents. I'll briefly show here the query development process using PyTigerGraph in Python. Here we can see we can extract the vertex and edge information, the number of vertices and edges in this particular graph that comprises 10 documents, and some queries on SDGs, documents, sentiment, and continent as well. Using our TigerGraph Studio tool, here I will demonstrate the entire graph, a visualization of the entire graph. Obviously very complex, and this is only 10 documents for demonstration purposes. Here we can run a query that outputs all the SDGs. Here's a query that outputs all the sentiments, and here, for example, on sentiment 2, anticipation, I can double click and determine which documents contain that sentiment. I think another more useful demonstration here is on the SDG. So let's say this particular query runs a query on SDG clean, where not all the documents are included, but you can double click there and then find the relationships there as well. There's more instructions on the GitHub repository, but this is an example of taking complex, broad, disparate, unstructured raw data in the form of PDF reports, and through the use of text mining, NLP, and graph database technology, specifically the tool set from TigerGraph, this information is now usable, searchable, and actionable. Thank you for your time. I look forward to